Hello everyone, welcome back to my YouTube channel again. Let's continue the problem of series parallel combination circuits for elements of electrical engineering as well as for introduction to electrical engineering. So you can see here a circuit consists of three resistors, 3 ohm, 4 ohm and 6 ohm are in parallel, and fourth resistor of 4 ohm is in series. Means there are three parallel combination circuit, that is 3 ohm, 4 ohm and 6 ohm, which are connected in parallel. And this combination is connected in series to 4 ohm in series. So across this resistor combination, there is a battery with a EMF of 12 volts and internal resistance of 6 ohm. You need to find total current in the circuit and terminal voltage across the battery. Battery means it is having an internal resistance R. You should find terminal voltage across that. First, you need to draw the circuit diagram. You can see here the 3 ohm, 4 ohm and 6 ohm which are connected in parallel. 3 ohm, 4 ohm, 6 ohm which are connected in parallel, and this combination is connected in series to 4 ohm. Across this you are connected one battery which has internal resistance of 6 ohm. This is a practical voltage source. If it is ideal voltage source, there is no internal resistance. You need to find voltage across this terminal, that is V terminal. You need to find voltage across 12 volts battery plus internal resistance of 6 ohm resistor. Before that, you need to find total current. So to find the total current, you know the total voltage, you know all the resistor values. You can get, you just apply Ohm's law, you'll get total current. That is I is given by V divided by R equivalent. So for that, first you need to find R equivalent so that you can get the value of R equivalent. 3 ohm is parallel to 4 ohm is parallel to 6, and this combination is connected series to 4 ohm, and also it is connected in series to 6 ohm. So you can see here 1 by 3 plus 1 by 4 plus 1 by 6. You'll get some answer. Reciprocal of this is R equivalent 1. Similarly, R equivalent 2 is 10 ohm. You can get total R equivalent as 11.33 ohm. So now you know the value of total voltage V, R equivalent. You can get the value of I is given by V divided by R equivalent. Therefore, 12 divided by 11.33, you can get 1.058 amperes. So next is you need to find voltage across terminal voltage across this battery. Means you need to get drop across these two. You know already it is having 12 volt source. Here you need to find the drop. Means current flows to this resistor into R. Therefore, you can get terminal voltage is given by 12 voltage minus I into R. That is minus current flows through the internal resistance into resistor. Okay. Then you can get 12 minus current you are calculated 1.058 into internal resistance is 6. You get 5.647. This is the final answer. So if you are having any doubts regarding this, feel free to write in the comment box. If you really like this video, kindly do subscribe. Thank you. Have a nice day.